Hello children, what's up? I think you are doing well. Yes, welcome again to chemistry class. Yesterday we discussed about, in the sense previous class we discussed about what? Mole concept. In this class also we are going to discuss about what? Mole concept only. But this is somewhat little bit extension to that. In the last class we discussed about atoms. This is somewhat simplest way to understand. This is somewhat little bit complexic, but it is also very easy. Yes, now the discussion is about molecules, right? So what is the mass of one nitrogen atom? We are already discussed in the previous class. It is nothing but it is consisting of 7 protons and 7 neutrons, right? So 7 into 1.67 into 10 to the power of minus 24 grams plus 7 into 1.67 into 10 to the power of minus 24 grams. So this is called AMU. So finally what we can say, mass of one nitrogen atom is 14 atomic mass units. So mass of 1 mole of nitrogen atoms is mass of 1 mole of nitrogen atoms. Mass of 1 mole of nitrogen atoms is equal to 14 AMU. 14 AMU into Avogadro number. This is only we discussed in the last class. 14 AMU in the sense 1 AMU is equal to this much grams. 1.67 into 10 to the power of minus 24 grams, right? Into 14 into Avogadro number 6.022 into 10 to the power of 23. We discussed everything. Here this one and this one is multiplied, you get 1. So it is nothing but 14 grams. Yes students, this is we discussed in the previous class. That is nothing but mass of one nitrogen atom is 14 atomic mass units. So mass of one mole of nitrogen is 14 grams. Yes, it is discussed already. Now I am going to giving you a clarity about AMU and grams. AMU is going to stands for mass of one atom, and grams is going to stands for 1 mole of atoms. So mass of one hydrogen atom is 1 AMU. Mass of 1 mole of hydrogen atoms is equal to 1 gram. Mass of one nitrogen atom is 14 AMU. Mass of 1 mole nitrogen is 14 grams. Mass of one oxygen atom is atom is 16 AMU, and mass of 1 mole oxygen atoms is 16 grams. That's it. This is called as what? Gram. This is called as what? Gram molar mass. So it is strictly an atom, right? Also called as gram atomic mass. This is what? Gram molar mass of nitrogen atom, otherwise gram atomic mass of nitrogen atom. Here this is what? Gram molar mass of oxygen atom or gram atomic mass of oxygen. So if they are giving you in AME, that is what? Strictly belongs to one atom. They are giving in grams, that is strictly belongs to 1 mole of atoms. Just keep this data in your mind, right? Pause the video or take the screenshot. Okay. Then when you come to molecules, students, when you come to molecules, suppose find mass of 1 mole of N2 molecules. Otherwise, find mass of 1 mole of N2. So, one N2 molecule has two nitrogen atoms, right? Right? Two nitrogen atoms, right? Therefore, mass of yes, one N2 molecule is yes, as we discussed in the previous class, mass of one nitrogen atom is 14 AMU. Here it has two nitrogen atoms, has 14 into, is 2 into 14 AMU, right? That is what? 28 AMU, right? This is mass of one N2 molecule, but we need mass of 1 mole of N2. Therefore, mass of 1 mole of N2 is equal to 1 mole of N2, right? So, mass of one molecule of N2, that is what? 28 AMU into Avogadro number, students. S 28 into 1 AMU is equal to 1.67 into 10 to the power of minus 24 grams into Avogadro number is 6.022 into 10 to the power of 23, right? So this is equal to 1. Here 28 grams is the gram molecular mass of nitrogen. This is called as gram molecular mass, otherwise gram molar mass of nitrogen. Gram molar mass in the sense, or gram molecular mass in the sense, it is the mass of 1 mole of molecules. Gram molar mass in the sense, it is the mass of 1 mole of molecules. AMU in the sense, mass of 1 molecule. 28 AMU is nothing but mass of 1 nitrogen molecule. 28 grams is nothing but mass of 1 mole of nitrogen molecules. I think you are getting, right? You are understanding, right? Now you tell fastly, try to answer this. What is the find here? You see? Yes, find mass of 1 mole O2. Yes. Mass of 1 oxygen atom is, yes, 16 AMU. We know this. So 1 O2 molecule mass is, otherwise mass of 1 O2 molecule, mass of 1 O2 molecule is, yes, 1 O2 molecule has 2 oxygen atoms. 1 oxygen atom atomic mass is 16 AMU. 2 oxygen atoms are there in 1 O2 molecule. So 2 into 16 AMU only. That is what? 32 AMU. This is the molecular mass of 1 oxygen molecule. 1 oxygen molecule. Then mass of 1 mole oxygen is 1 mole oxygen molecules is equal to, that is what? 1 molecule mass 32 AMU into what? Avogadro number, students. That is nothing but what? 32 into 1 AMU is equal to 1.67 into 10 to the power of minus 24 grams into 6.022 into 10 to the power of 23. That is what? Avogadro number. Right. So that is what? Yes, this calculation is equal to 1. Answer is what? 32 grams. This is gram molecular mass of oxygen, O2. Gram molecular mass of oxygen, O2, students. Likewise, we can easily find out. Right. See. See here. What is the gram molecular mass of sulfur, otherwise gram molar mass of sulfur. See here. So mass of one sulfur atom is equal to, sulfur atomic number is what, 32, right? Yes, sorry, 16 it is. 16, sulfur atomic number is what it is? 16. 16 in the sense what? 16 protons are there, 16 neutrons are there, right? That is what? Yes, 16 into, otherwise 16 into 1.67 into 10 to the power of minus 24 plus 16 into 1.67 into 10 to the power of minus 24. This is mass of proton, this is mass of neutron. So 32 into this value, 1.67 into 10 to the power of minus 24. This is nothing but AMU. 32 AMU. 1 AMU is equal to this much grams. So we know that. So mass of 1 mole sulfur is equal to mass of 1 atom sulfur. Mass of 1 atom of sulfur is 32 AMU into Avogadro number you have to take. That is 32 AMU. AMU in the sense what? How many grams? 1.67 into 10 to the power of minus 24 grams into 6.022 into 10 to the power of 23. Then S, this calculation is equal to 1. So it is what? 32 grams, students. So this is what? Gram molar mass of sulfur. Gram molar mass of sulfur. Okay, right. Take down. Right. Pause the video and take the notes. Otherwise, take a screenshot. Right. Suppose there is 98 grams of H2SO4. Suppose they want to ask find number of sulfur atoms. Sulfur atoms they are asking. Find number of sulfur atoms in this much of sample. 98 grams of H2SO4. How many sulfur atoms are there? That is their question. First of all, to find sulfur atoms, you have to get number of moles. You have to get number of moles of given sample. Number of moles of given sample. So there is a formula to get moles when weight is given, students. There is a formula to get number of moles when weight of the substance is given. So this is what? When weight of the substance is given. Formula for moles. So number of moles is equal to given mass, otherwise given weight by gram molar mass of the substance. So given mass is what? 98 grams. And what is the gram molar mass of H2SO4? What is the gram molar mass of H2SO4? For hydrogen, gram molar mass is 1. For sulfur, gram molar mass is 32 grams. For 1 oxygen, gram molar mass is 16 grams. Yes. Gram molar mass of hydrogen is 1. Otherwise, atom, right? Gram atomic mass or gram molar mass, whatever it is. For 1 mole of hydrogen, this. Gram atomic mass or gram molar mass of sulfur is 32. Gram atomic mass or gram molar mass of each oxygen is 16. Just now you calculate how many hydrogens are there. 2 into each one has gram molar mass is 1 plus 1 sulfur is there. 1 into sulfur gram molar mass is 32 plus how many oxygens are there? 4 into each one has 16 grams. So gram molar mass of H2SO4 is equal to what, students? Yes, 2 plus 32 plus 64, it is 2 plus 32 plus 64, it is again 98 grams. Wow. So easy calculation, that is what 98 by 98, this is 1 mole. 98 grams of, in the problem what they are giving, 98 grams of H2SO4, right? This means it is nothing but 1 mole of H2SO4 is given. 98 grams of H2SO4 is nothing but 1 mole of H2SO4. It is equal to 1 mole. 98 grams is equal to 1 mole. How to calculate number of moles when weight of the substance is given? So number of moles equal to given mass by gram molecular mass of the substance. By knowing these gram molar masses of atoms, we can get the gram molecular mass of the given substance like this by adding like this. How many atoms are there? 2. Each one has 1 gram atomic mass or 1 gram molar mass, not molecular mass, molar mass. Right. Like that we can easily calculate. So it is 1 mole. Yes, students. So the given substance is 1 mole. Therefore 1 mole of any yes. See, 1 mole is nothing but what? Avogadro number, right? 1 mole is nothing but what? Avogadro number. So in 1 H2SO4, there is one sulfur atom is present, right? Atom is present. So in one single molecule, one single sulfur atom is there. In 1 mole H2SO4, this is your answer now. In 1 mole H2SO4, so 1 mole of sulfur is there. 1 mole in the sense, 1 mole of sulfur atoms are there. 1 mole of sulfur atoms are there. Therefore, 1 mole of atoms in the sense, 1 mole of atoms in the sense is nothing but Avogadro number 6.022 into 10 to the power of 23 sulfur atoms are present. Sulfur atoms are present in this given data, students. In this given data, in 98 grams of H2SO4, this much number of sulfur atoms are present. Let me explain once again here. This is the given data. There is 98 grams of H2SO4. The question is, find number of sulfur atoms. First of all, you have to find number of moles according to the given data, right? So here the given data is weight. I am giving you a small formula to find number of moles when weight of the substance is given. Number of moles is equal to given mass by gram molecular mass. That is, given mass is 98 and we calculated here gram molecular mass of the given substance by means of these values, right? Again it is what you got, 98 by 98 is 1 mole is given in the question. 98 grams of H2SO4 in the sense it is 1 mole. Just keep in your mind, in 1 molecule of H2SO4 there is 1 sulfur atom. Just now you take 1 molecule of H2SO4. In 1 molecule of H2SO4 there is 1 sulfur atom. In 1 mole of H2SO4, 1 mole of sulfur atoms are there. In 1 mole of H2SO4, 1 mole of sulfur atoms are there. So 1 mole of sulfur atoms in the sense 1 mole contains 6.022 into 10 to the power of 23 sulfur atoms. That is your answer. Your answer is what? 1 mole of sulfur atoms. In the sense, Avogadro number of sulfur atoms are there. There what? 6.022 into 10 to the power of 23 sulfur atoms are present. Right? So in the same question, students, in the same question, how many hydrogen atoms are present means? How many hydrogen atoms are present? How many hydrogen atoms are present? How many hydrogen atoms are present? That is my question. Yes. So number of moles is equal to 1 as we already calculated. So one molecule has two hydrogen atoms, right? One molecule of H2SO has two hydrogen atoms. So 1 mole of H2SO4 contains yes, one molecule there are two hydrogen atoms. 1 mole there are 2 mole of hydrogen atoms. There are 2 moles of hydrogen atoms. So therefore number of hydrogen atoms is equal to 1 mole contains Avogadro number. 2 moles contains number of hydrogen atoms in 2 moles. In 2 moles is equal to 2 into Avogadro number. That is nothing but 2 into number of hydrogen atoms of 2 moles. Yes, 2 moles of hydrogen atoms are there. And how many number of hydrogen atoms in 2 moles is nothing but 2 into Avogadro number. 2 into 6.022 into 10 to the power of 23. Hydrogen atoms are present in this same question, in the same data, from the same data. I think you're getting the problems, right? Any doubts are there? Just you contact me, no problem, right? Yes. Yes, I am giving you some other two formulas, just you memorize them. Number of moles when volume is given. Volume is given at STP, standard temperature pressure, right? So that is nothing but given volume by gram molar volume. So gram molar volume is nothing but volume occupied by 1 mole of any gas, any ideal gas at STP. We know that value in your lower classes, that is what, 22.4 liters, students. So this you have to substitute here. Yes, for your information I am giving you 22.4 liters is equal to 22.4 decimeter cube. That is also equal to 22400 milliliters. That is also equal to, yes, 22400 centimeter cube. You have to memorize these values regarding conversions. Otherwise, to understand the problem, so first of all, what is gram molar volume, students? Volume occupied by 1 mole of any ideal gas at STP is equal to 22.4 liters. 22.4 liters. Yes. So how to find number of moles of any given volume of the gas? This is the formula. Number of moles when volume is given at STP, that is equal to given volume by gram molar volume, students. Given volume by gram molar volume. What is gram molar volume? Volume occupied by 1 mole of gas, 1 mole of any gas, otherwise 1 mole of any ideal gas at STP is equal to 22.4 liters. Yes, in any question they given 22.4 decimeter cube, it is nothing but 22.4 liters. It is nothing but 22,400 milliliters, or it is equal to 22,400 centimeter cube. That those the conversions to understand the problem, otherwise to understand the data which is given in the problem. This is one more formula to find number of moles when volume is given, students. So another important formula is there. Another important formula is there to find moles. That is nothing but when number of entities are given, number of atoms, number of ions, number of molecules are given, right? So number of moles when entities are given, entities in the sense atoms, number of atoms, or number of molecules, or number of particles, number of stones, like that. So the formula to find, otherwise how to convert atoms into moles, how to convert atoms into molecules, how to convert molecules into moles, how to convert number of particles into moles. So number of moles in this condition is equal to given number of entities divided by just Avogadro number. That's it. Number of moles is equal to given number of entities by Avogadro number. That's it. You will convert number of atoms into moles. You will convert number of molecules into moles. You will definitely convert number of particles into moles. You getting my point? By memorizing all these formulas and by memorizing molecular masses, molar masses, what is the difference between AMU and gram molar mass? So stoichiometry becomes very easy. Stoichiometry in the sense all physical chemistry calculations are very easy, right? Just we'll discuss more and more problems in coming classes. Just memorize all these formulas. So when mass is given, number of moles is equal to given mass by molar mass. When volume is given, number of moles is equal to given volume by gram molar volume, that is what, 22.4 liters. When number of entities are given, number of moles is equal to given number of entities by Avogadro number. You know Avogadro number, right? Right. 6.022 into 10 to the power of 23 entities. Avogadro number is nothing but, that is what, 6.022 into 10 to the power of 23 entities. This is a number, that's it. So this is what about mole concept. In the next class we are going to discuss some problems regarding this mole concept. Okay, thank you.